Hello, beautiful souls. Welcome to this quiet space, a place where minds slow down and memory rests. Before we begin this gentle, sleepy journey, just a small moment of support. If this meditation brings you calm, comfort, or clarity, please subscribe to the channel, gently tap the like button, and leave a comment to let us know you are here. Your support helps us continue creating these peaceful spaces for your mind, for your memory. Now, there is nothing else you need to do, nothing to think about. Let's begin. Close your eyes now and slowly settle into a comfortable position. Take a gentle breath in and slowly breathe out. Let your shoulders relax, let your jaw loosen, and allow your whole body to feel heavy. Now, imagine we are beginning a quiet journey, not to outer space, not to deep oceans, but to a place much closer. Inside your mind rests something very important, something that works while you rest, something that guides your days, your memory. Your memory is natural. Your memory is essential. It is ready to work. Tonight, we will travel through the quiet, gentle world inside your own mind, where memories are stored, where memories are protected, where memories are quietly, gently strengthened. Memory is one of the most fundamental abilities of the human brain. Memory allows us to hold information. Memory allows us to keep experiences with us. Memory allows us to learn. Memory allows us to recognize people and places. Memory allows us to navigate the world. Without memory, we would not know who we are. Without memory, we would not know where we are. Without memory, we would not be able to function in daily life. Memory is essential. Memory is constant. Memory is happening all the time, even when we are not aware of it. When we talk about memory, we are talking about the brain's ability to encode information, store that information, and retrieve that information later. Encoding means taking in information from the world. Storing means keeping that information over time. Retrieving means bringing that information back into awareness. These three processes work together. They work slowly. They work quietly. They happen in the background of our minds. Memory is not one single thing. Memory is made up of many different systems. These systems work in different ways. These systems involve different parts of the brain. Some memories last only a few seconds. Some memories last a lifetime. Some memories are about facts. Some memories are about experiences. Some memories are about how to do things. All of these are forms of memory. All of these are important. Humans need memory for survival. Memory helps us remember where we found food. Memory helps us remember who is safe and who is dangerous. Memory helps us learn from mistakes. Memory helps us repeat successful behaviors. Memory helps us communicate. Memory helps us maintain relationships. Memory connects our past to our present. Memory allows us to plan for the future. Without memory, there is no sense of time. Without memory, there is no sense of self. Remembering is the process of bringing information back into awareness. Forgetting is the process of losing access to information. Both are natural. Both happen constantly. Forgetting is not always a failure. Sometimes forgetting is helpful. Forgetting allows us to let go of unimportant details. Forgetting prevents our minds from becoming overwhelmed. The brain cannot store everything. The brain must be selective. What we remember and what we forget is determined by many factors. Some of these factors we can control. Some of these factors we cannot control. Let us now turn to the different types of memory. Memory can be divided into different categories based on how long information is held and what kind of information is being held. The first major division is between short-term memory and long-term memory. Short-term memory holds information for a brief period. Long-term memory holds information for extended periods, sometimes for an entire lifetime. These two systems work differently. They involve different brain regions. They serve different purposes. Short-term memory is the ability to hold a small amount of information in mind for a short period of time. This period is usually measured in seconds. When you hear a phone number and repeat it in your mind before writing it down, you are using short-term memory. When you read a sentence and hold the beginning of the sentence in mind while you finish reading it, you are using short-term memory. Short-term memory is limited. It can hold only a small amount of information. Most people can hold about 7 items in short-term memory at once. Some people can hold a bit more. Some people can hold a bit less. This capacity is limited by the way the brain works. Short-term memory is fragile. If you are distracted, the information disappears. If you do not rehearse the information fades. Short-term memory is constantly being refreshed and replaced. New information comes in. Old information goes out. This process happens quickly. This process happens automatically. You do not have to think about it. Your brain manages this process without your conscious effort. Working memory is closely related to short-term memory. Working memory is the ability to hold information in mind and manipulate it. Working memory allows you to do mental math. Working memory allows you to follow directions. Working memory allows you to hold a conversation. When you hold information in mind and also do something with that information, you are using working memory. Working memory is active. Working memory requires attention. Working memory is more demanding than simply holding information passively. Working memory involves several parts of the brain. The prefrontal cortex, located at the front of the brain, plays a major role in working memory. The prefrontal cortex helps organize information. The prefrontal cortex helps prioritize information. The prefrontal cortex helps keep irrelevant information out. Working memory is essential for reasoning, for problem solving, for decision making. Working memory is active throughout the day. Working memory becomes tired when we are fatigued. Working memory becomes less effective when we are stressed. Long-term memory is different from short-term memory in many ways. Long-term memory can hold vast amounts of information. Long-term memory can hold information for years. Long-term memory can hold information for an entire lifetime. The capacity of long-term memory is enormous. No one knows exactly how much information long-term memory can hold. It appears to be nearly limitless. Long-term memory is more stable than short-term memory. Information in long-term memory does not disappear just because you are distracted. Information in long-term memory can be retrieved later, even if you have not thought about it in a long time. Long-term memory itself can be divided into different types. One major division is between explicit memory and implicit memory. Explicit memory is memory that you can consciously recall. Explicit memory includes memories of facts and memories of events. When you remember what you had for breakfast, you are using explicit memory. When you remember the capital of a country, you are using explicit memory. Explicit memory requires conscious effort to retrieve. You know that you are remembering something. Implicit memory is memory that influences your behavior without conscious awareness. Implicit memory includes skills, habits, and conditioned responses. When you ride a bicycle, you are using implicit memory. You do not have to consciously remember how to balance or how to pedal. Your body remembers. When you type on a keyboard, you are using implicit memory. Your fingers know where the keys are without you having to think about it. Implicit memory works automatically. Implicit memory works in the background. You may not even realize that memory is involved. Within explicit memory, there are two main types: episodic memory and semantic memory. Episodic memory is memory for personal experiences. Episodic memory is memory for events that happen to you. Episodic memory includes a sense of time and place. When you remember your last birthday, you are using episodic memory. When you remember a conversation you had yesterday, you are using episodic memory. Episodic memory is rich with detail. Episodic memory includes sensory information, emotional information, contextual information. Episodic memory feels personal. Episodic memory is about your life. Semantic memory is memory for facts and knowledge. Semantic memory does not include a sense of time and place. Semantic memory is more abstract. When you know that Paris is the capital of France, you are using semantic memory. You probably do not remember when or where you learned this fact. You just know it. When you know what a dog is, you are using semantic memory. You know the concept of a dog without having to remember every dog you have ever seen. Semantic memory is essential for understanding language, for understanding concepts, for understanding the world. Procedural memory is a type of implicit memory. Procedural memory is memory for skills and procedures. Procedural memory is memory for how to do things. When you learn to play a musical instrument, you are building procedural memory. When you learn to drive a car, you are building procedural memory. Procedural memory develops through practice. Procedural memory develops through repetition. The more you practice a skill, the stronger the procedural memory becomes. Once a skill is learned, it becomes automatic. You do not have to think about each step. Your brain and body know what to do. All of these types of memory work together. They interact with one another. They support one another. A single experience can involve multiple types of memory. When you learn to cook a new recipe, you use working memory to follow the steps. Episodic memory to remember where you learned the recipe. Semantic memory to understand the ingredients. And procedural memory to develop the physical skills of chopping and stirring. Memory is complex. Memory is interconnected. Memory is not stored in one single place in the brain. Now let us turn to how memory is formed in the brain. Memory formation is a biological process. Memory formation involves changes in brain cells. Brain cells are called neurons. Neurons are the basic units of the nervous system. The human brain contains approximately 86 billion neurons. Each neuron can connect to thousands of other neurons. These connections form vast networks. These networks allow neurons to communicate with one another. Communication between neurons is how information is processed. Communication between neurons is how memory is formed. Neurons have a cell body, dendrites, and an axon. The cell body contains the nucleus and other structures that keep the cell alive. Dendrites are branching structures that receive signals from other neurons. The axon is a long fiber that sends signals to other neurons. At the end of the axon are axon terminals. Axon terminals release chemicals that carry signals to the next neuron. The point where one neuron communicates with another neuron is called a synapse. The synapse is a tiny gap between neurons. Communication across the synapse is chemical. It is also electrical. But at the synapse itself, the communication is chemical. When a neuron is activated, an electrical signal travels down the axon. When the electrical signal reaches the axon terminal, it triggers the release of neurotransmitters. Neurotransmitters are chemical messengers. They cross the synapse and bind to receptors on the dendrite of the next neuron. When neurotransmitters bind to receptors, they change the activity of the receiving neuron. The receiving neuron may become more likely to fire, or the receiving neuron may become less likely to fire. This depends on the type of neurotransmitter and the type of receptor. This process happens very quickly. This process happens constantly throughout the brain. Memory formation involves changes at the synapse. When neurons communicate repeatedly, the connection between them can become stronger. This is called synaptic strengthening. When neurons communicate less frequently, the connection between them can become weaker. This is called synaptic weakening. Synaptic strengthening and synaptic weakening allow the brain to adapt. They allow the brain to learn. They allow the brain to form memories. This process is often summarized by the phrase, neurons that fire together, wire together. When two neurons are active at the same time, the connection between them becomes stronger. This is the basis of learning. This is the basis of memory. The strengthening of synapses is not immediate. It takes time. It requires repeated activity. When you learn something new, neurons fire in a particular pattern. If this pattern is repeated, the connections in that pattern become stronger. If the pattern is not repeated, the connections remain weak or fade away. This is why practice is important. This is why repetition is important. Repetition strengthens the neural pathways that represent what you are learning. Repetition makes retrieval easier later. At the molecular level, synaptic strengthening involves changes in proteins. Proteins are the building blocks of cells. When a synapse is activated repeatedly, new proteins are produced. These proteins change the structure of the synapse. They make the synapse more efficient. They increase the number of receptors. They increase the release of neurotransmitters. These changes can last for hours, days, or even years. The longer the changes last, the more stable the memory becomes. One important process in synaptic strengthening is called long-term potentiation. Long-term potentiation is a long-lasting increase in the strength of a synapse. Long-term potentiation occurs when a synapse is activated repeatedly in a short period of time. This repeated activation triggers biochemical changes that strengthen the synapse. Long-term potentiation has been studied extensively in a brain region called the hippocampus. The hippocampus is essential for forming new explicit memories. Long-term potentiation in the hippocampus is thought to be one of the key mechanisms for encoding new memories. The hippocampus is a small, curved structure located deep in the brain. There's one hippocampus on each side of the brain. The hippocampus plays a critical role in memory formation. When you experience something new, the hippocampus helps bind together different pieces of information. It helps link the sights, sounds, smells, and emotions of an experience into a single memory. The hippocampus does not store memories permanently. Instead, it helps encode memories and supports their consolidation. Over time, memories become less dependent on the hippocampus. They become stored in other parts of the brain, particularly in the cortex. The cortex is the outer layer of the brain. The cortex is divided into many regions. Each region has specialized functions. Visual information is processed in the visual cortex at the back of the brain. Auditory information is processed in the auditory cortex on the sides of the brain. Motor information is processed in the motor cortex near the top of the brain. Memories are distributed across these regions. A memory of a visual scene is stored in the visual cortex. A memory of a sound is stored in the auditory cortex. The hippocampus helps coordinate these distributed pieces of information during encoding and retrieval. Now let us turn to how memories are stored over time. Memory storage is not like saving a file on a computer. Memory storage is an active, dynamic process. When a memory is first formed, it is fragile. It can be easily disrupted. Over time, the memory becomes more stable. This process is called consolidation. Consolidation involves the transfer of information from the hippocampus to the cortex. Consolidation involves the strengthening of synapses. Consolidation requires time. Consolidation requires rest. Consolidation often requires sleep. Sleep plays a crucial role in memory consolidation. During sleep, the brain replays the experiences of the day. Neurons that were active during waking are reactivated during sleep. This reactivation strengthens the connections that represent those experiences. This process happens during specific stages of sleep. During deep, slow-wave sleep, the hippocampus replays memories and transfers them to the cortex. During REM sleep, the brain integrates new memories with existing knowledge. Both stages of sleep are important for memory. Lack of sleep impairs memory consolidation. Lack of sleep makes it harder to form new memories. Lack of sleep makes it harder to retrieve old memories. Consolidation is not a one-time event. Consolidation can occur over days, weeks, months, or even years. Each time a memory is retrieved, it becomes temporarily fragile again. Then it must be reconsolidated. Reconsolidation allows memories to be updated. It allows new information to be integrated into existing memories. This is why memories can change over time. This is why memories are not perfect recordings. Memories are reconstructions. Each time you remember something, you are rebuilding the memory from fragments. Each time you rebuild the memory, it can change slightly. The process of consolidation involves not just the hippocampus and cortex, but many other brain regions as well. The amygdala, a small, almond-shaped structure deep in the brain, is involved in consolidating emotional memories. When an experience has strong emotional content, the amygdala helps strengthen the memory. This is why emotional events are often remembered more vividly than neutral events. Emotional arousal enhances memory consolidation. This happens automatically. You do not have to try to remember emotional events. Your brain prioritizes them. Another important brain region for memory is the prefrontal cortex. The prefrontal cortex is involved in organizing memories, in retrieving memories, and in keeping memories in working memory. The prefrontal cortex helps you search for information in long-term memory. The prefrontal cortex helps you suppress irrelevant memories. The prefrontal cortex is involved in metamemory, which is knowing what you know and what you do not know. Damage to the prefrontal cortex can impair memory retrieval even when the memories themselves are intact. The cerebellum, located at the back and bottom of the brain, is involved in procedural memory. The cerebellum helps coordinate movement. The cerebellum helps learn motor skills. When you practice a physical skill, the cerebellum forms memories of the movements. These memories allow you to perform the skill smoothly and automatically. The cerebellum works largely outside of conscious awareness. You are not aware of the cerebellum's role in memory. But without the cerebellum, learning new motor skills would be very difficult. Memory storage involves changes not just in individual synapses, but in entire networks of neurons. When a memory is formed, a specific pattern of neurons becomes active. This pattern is sometimes called an engram or a memory trace. The engram is distributed across many neurons. The engram is not localized to one place. Retrieving the memory means reactivating the same pattern of neurons. If the pattern is reactivated completely, the memory is recalled clearly. If the pattern is only partially reactivated, the memory is recalled incompletely or with errors. Now let us turn to how the brain retrieves memories. Retrieval is the process of bringing information from long-term memory back into conscious awareness. Retrieval is not like opening a file. Retrieval is an active reconstruction. When you try to remember something, the brain searches for cues. Cues are pieces of information that are associated with the memory. If you can find the right cue, the memory is more likely to be retrieved. If the cue is weak or ambiguous, retrieval may fail. This is why context is important. Remembering is often easier when you are in the same context where the memory was formed. Retrieval can be slow. Retrieval can be effortful. Sometimes you know that you know something, but you cannot quite bring it to mind. This is called the tip of the tongue phenomenon. The information is stored in long-term memory, but you cannot access it at that moment. The retrieval cue is not strong enough. If you wait, if you relax, if you think about related information, the memory may come to you later. This is because retrieval involves spreading activation. When you think about one piece of information, activation spreads to related pieces of information. Eventually, the target memory may be activated. Retrieval is influenced by many factors. Attention is important. If you are distracted, retrieval is slower and less accurate. Fatigue impairs retrieval. Stress impairs retrieval. Emotional state can influence what you remember. When you are sad, you are more likely to remember sad events. When you are happy, you are more likely to remember happy events. This is called mood-congruent memory. The brain is constantly influenced by internal states. These internal states shape what is retrieved and how it is retrieved. Retrieval also depends on the strength of the memory. Strong memories are easier to retrieve. Weak memories may be difficult or impossible to retrieve. Strength is determined by how well the memory was encoded and how often it has been retrieved. Each time you retrieve a memory, you strengthen it. This is called the testing effect. Practicing retrieval is one of the most effective ways to strengthen memory. Simply rereading information is less effective than trying to recall the information from memory. Retrieval practice forces the brain to reconstruct the memory. This reconstruction strengthens the neural pathways. Sometimes retrieval produces errors. You may remember something that did not happen. You may remember something differently from how it actually happened. These are called false memories. False memories are not lies. They are genuine mistakes. The brain fills in gaps with plausible information. The brain combines information from different sources. Over time, the source of the information is forgotten. You may remember something you imagined as if it were real. You may remember something someone told you as if you experienced it yourself. False memories demonstrate that memory is reconstructive, not reproductive. Now let us turn to why humans forget. Forgetting is a natural part of memory. Forgetting happens to everyone. Forgetting can be frustrating, but it is not always a sign of a problem. Forgetting serves a purpose. Forgetting allows the brain to discard unimportant information. If we remembered everything, the brain would be overwhelmed. Forgetting allows the brain to prioritize important information. Forgetting allows the brain to update information. Forgetting is adaptive. One reason we forget is decay. Decay is the fading of memory over time. If a memory is not retrieved, the synaptic connections that represent the memory gradually weaken. The memory becomes harder to access. Eventually, the memory may be lost entirely. Decay happens naturally. Decay is more likely for memories that are not important, not distinctive, or not rehearsed. Decay happens slowly. Some memories decay in days. Some memories decay in years. Some memories never decay at all. Another reason we forget is interference. Interference occurs when other information disrupts the retrieval of a memory. There are two types of interference: proactive and retroactive. Proactive interference occurs when old information interferes with new information. If you learn a new phone number, your old phone number may interfere. You may accidentally recall the old number instead of the new one. Retroactive interference occurs when new information interferes with old information. If you learn a new password, it may interfere with your memory of the old password. Interference is especially strong when the information is similar. Forgetting can also occur because of retrieval failure. The memory is still stored in the brain, but you cannot access it at the moment. Retrieval failure is often temporary. If you are given the right cue, the memory can be retrieved. If you return to the context where the memory was formed, the memory is more likely to come back. This is why going back to a room where you forgot something can help you remember. The context provides retrieval cues. Retrieval failure shows that forgetting is not always about loss of information. Sometimes it is about loss of access. Forgetting can also be influenced by emotional factors. Traumatic memories may be suppressed. Suppression is a process where the brain actively inhibits the retrieval of a memory. Suppression can be intentional or unintentional. Intentional suppression occurs when you try not to think about something. Unintentional suppression occurs when the brain automatically blocks painful memories. Suppression can be adaptive in the short term. It allows you to function, but in the long term, suppressed memories may still influence behavior and emotions. Suppression does not erase memories. It only makes them harder to access. Forgetting is more common for some types of information than others. Details are forgotten more easily than general information. Exact wording is forgotten quickly. The gist is retained longer. Unimportant information is forgotten more easily than important information. Emotional information is often retained better than neutral information. These patterns reflect the brain's priorities. The brain retains what is most useful. The brain discards what is less useful. Forgetting increases with age. But this does not happen suddenly. Forgetting is a gradual process. It begins in early adulthood. Memory performance peaks in the 20s. After that, there is a slow decline. The decline is not the same for all types of memory. Some types of memory are more affected by aging than others. Let us explore how memory changes across the lifespan. In childhood, memory develops rapidly. Infants have memory from birth. Even newborns can recognize their mother's voice. But early memories are fragile. Most people do not remember events from the first few years of life. This is called childhood amnesia. Childhood amnesia occurs because the hippocampus and prefrontal cortex are still developing. These brain regions are essential for forming and retrieving explicit memories. As the brain matures, memory improves. By the age of 5 or 6, children can form stable, long-term memories. Memory continues to improve through childhood and adolescence. Working memory capacity increases. The ability to use memory strategies improves. Children learn to rehearse information, to organize information, to use mnemonic devices. These strategies make encoding and retrieval more effective. The brain continues to develop into the mid-20s. The prefrontal cortex is one of the last brain regions to fully mature. As the prefrontal cortex matures, the ability to control attention and to use working memory improves. In young adulthood, memory is at its peak. Young adults can learn new information quickly. They can hold more information in working memory. They can retrieve information efficiently. Episodic memory is strong. Semantic memory is strong. Procedural memory is strong. The brain is efficient. The synapses are strong. The neurons communicate effectively. This is the time of life when memory capacity is greatest. In middle age, some aspects of memory begin to decline. The decline is slow. The decline is subtle. Most people do not notice it at first. Working memory capacity may decrease slightly. Retrieval may become a bit slower. Tip of the tongue experiences may become more common. But not all aspects of memory decline. Semantic memory often remains stable or even improves. Knowledge continues to accumulate. Expertise continues to grow. Older adults may know more than younger adults, even if retrieval is slower. In older age, memory decline becomes more noticeable. Episodic memory is particularly affected. Older adults may have difficulty remembering recent events. They may have difficulty remembering where they put something. They may have difficulty remembering names. But these changes are normal. They do not necessarily indicate a serious problem. The brain is aging. Neurons are less efficient. Synapses are weaker. The hippocampus may shrink slightly. The prefrontal cortex may shrink slightly. These changes are part of normal aging. Not all older adults experience the same degree of memory decline. Some older adults maintain excellent memory into their 80s and 90s. Factors that protect memory include physical exercise, mental activity, social engagement, and a healthy diet. Physical exercise increases blood flow to the brain. Physical exercise promotes the growth of new neurons in the hippocampus. Mental activity keeps the brain engaged. Learning new skills, solving puzzles, reading, and engaging in hobbies all support brain health. Social engagement provides cognitive stimulation and emotional support. A healthy diet provides the nutrients the brain needs. Memory decline in older age is not the same as dementia. Dementia is a serious condition that involves severe memory loss and other cognitive impairments. Dementia is not a normal part of aging. Dementia is caused by diseases that damage the brain. Alzheimer's disease is the most common cause of dementia. Alzheimer's disease involves the buildup of abnormal proteins in the brain. These proteins damage neurons and synapses. Memory loss in Alzheimer's disease is progressive. It worsens over time. It eventually interferes with daily functioning. Normal age-related memory decline is much milder. It does not interfere significantly with daily life. Now, let us turn to how stress, fatigue, and lack of sleep affect memory. Stress affects memory in complex ways. Mild stress can enhance memory. When you are slightly stressed, the brain releases hormones like cortisol and adrenaline. These hormones increase alertness. They increase attention. They enhance encoding. This is why you often remember stressful events vividly. But chronic stress impairs memory. When stress is prolonged, cortisol levels remain high. High cortisol levels damage the hippocampus. The hippocampus shrinks. Synapses are weakened. Memory formation is impaired. Chronic stress also impairs retrieval. When you are stressed, it is harder to access information in long-term memory. Stress affects working memory as well. When you are stressed, working memory capacity decreases. It becomes harder to hold information in mind. It becomes harder to manipulate information. This is why it is difficult to think clearly when you are stressed. The prefrontal cortex is impaired by stress. The prefrontal cortex cannot function optimally. Attention wanders. Irrelevant information intrudes. Working memory performance suffers. Fatigue also impairs memory. When you are tired, the brain is less efficient. Neurons do not communicate as effectively. Attention is reduced. Encoding is impaired. If you are trying to learn something when you are tired, you will encode it poorly. Retrieval is also impaired by fatigue. When you are tired, it is harder to search long-term memory. It is harder to activate the right neural patterns. Retrieval becomes slow and effortful. Errors become more common. Lack of sleep has profound effects on memory. Sleep is essential for memory consolidation. Without adequate sleep, memories are not consolidated effectively. Information learned during the day is not transferred from the hippocampus to the cortex. The memories remain fragile. They are easily forgotten. Studies have shown that people who sleep after learning perform better on memory tests than people who stay awake. Sleep enhances memory. Sleep protects memory. Sleep is not wasted time. Sleep is when the brain does essential work. Lack of sleep also impairs encoding. When you are sleep deprived, the hippocampus is less active. The hippocampus cannot encode new information effectively. You may feel like you are learning, but the information is not being stored properly. Lack of sleep impairs attention. When attention is impaired, encoding is impaired. You cannot remember what you did not pay attention to. Sleep deprivation creates a vicious cycle. Poor Poor sleep leads to poor encoding. Poor encoding leads to poor memory. Poor memory creates stress and frustration. Stress and frustration make it harder to sleep. Chronic sleep deprivation can have long-term effects on memory and brain health. Studies suggest that chronic lack of sleep may increase the risk of cognitive decline and dementia. During sleep, the brain clears waste products that accumulate during waking. One of these waste products is a protein called beta-amyloid. Beta-amyloid is associated with Alzheimer's disease. If beta-amyloid is not cleared effectively, it can build up and damage neurons. Sleep is protective. Sleep is restorative. Sleep is essential for brain health. The relationship between memory and brain health is complex. Memory depends on healthy neurons, healthy synapses, and efficient communication between brain regions. Anything that damages the brain can impair memory. Head injuries can damage the hippocampus or other memory-related brain regions. Stroke can damage brain tissue and disrupt neural networks. Infections, toxins, and nutritional deficiencies can all affect memory. The brain is vulnerable. The brain requires care. Protecting the brain protects memory. Let us now return to the main ideas about memory and review them slowly and gently. Memory is the brain's ability to encode, store, and retrieve information. Memory is essential for learning. Memory is essential for functioning. Memory is essential for identity. Without memory, we would not know who we are. Without memory, we would not know where we are. Without memory, we would not be able to navigate the world. Memory is fundamental. Memory is constant. Memory shapes our experience of life. Memory is not one single system. Memory is made up of many systems. These systems work together. These systems involve different parts of the brain. Short-term memory holds information briefly. Working memory allows us to manipulate information. Long-term memory stores information for extended periods. Within long-term memory, there are different types. Explicit memory includes episodic memory and semantic memory. Implicit memory includes procedural memory. Each type of memory has its own characteristics. Each type of memory serves a different purpose. Memory is formed through changes in neurons and synapses. Neurons are brain cells. Neurons communicate through synapses. When neurons fire together repeatedly, the synapses between them strengthen. This strengthening is the basis of learning. This strengthening is the basis of memory. Long-term potentiation is one mechanism of synaptic strengthening. The hippocampus plays a key role in forming new explicit memories. The cortex stores memories long-term. The amygdala strengthens emotional memories. The prefrontal cortex organizes and retrieves memories. The cerebellum supports procedural memories. Memory involves the whole brain. Memory consolidation is the process of stabilizing memories over time. Consolidation involves the transfer of information from the hippocampus to the cortex. Consolidation requires time. Consolidation requires rest. Consolidation often requires sleep. During sleep, the brain replays experiences. During sleep, synapses are strengthened. During sleep, memories are integrated with existing knowledge. Sleep is essential for memory. Without sleep, consolidation is impaired. Without sleep, memories are fragile. Sleep protects memory. Sleep enhances memory. Sleep is not optional. Sleep is necessary. Retrieval is the process of accessing stored information. Retrieval is an active reconstruction. Retrieval depends on cues. Retrieval depends on context. Retrieval depends on the strength of the memory. Strong memories are easier to retrieve. Weak memories may be difficult or impossible to retrieve. Retrieval is influenced by attention, by fatigue, by stress, by emotional state. Retrieval can produce errors. False memories can occur. Memory is not a perfect recording. Memory is a reconstruction. Each time we remember, we rebuild the memory. Each time we rebuild it, it can change slightly. Forgetting is natural. Forgetting happens to everyone. Forgetting serves a purpose. Forgetting allows the brain to discard unimportant information. Forgetting allows the brain to prioritize. Forgetting occurs through decay, through interference, through retrieval failure. Decay is the fading of memory over time. Interference occurs when other information disrupts retrieval. Retrieval failure occurs when the memory is stored but cannot be accessed. Forgetting is not always a sign of a problem. Forgetting is part of how memory works. Memory changes across the lifespan. In childhood, memory develops rapidly. The hippocampus and prefrontal cortex mature. Memory capacity increases. In young adulthood, memory is at its peak. In middle age, memory begins to decline slightly. In older age, memory decline becomes more noticeable. Episodic memory is particularly affected, but semantic memory often remains stable. Not all older adults experience the same degree of decline. Factors like physical exercise, mental activity, social engagement, and a healthy diet protect memory. Normal age-related memory decline is gradual and mild. It is not the same as dementia. Stress affects memory. Mild stress can enhance memory. Chronic stress impairs memory. Chronic stress damages the hippocampus. Chronic stress impairs working memory. Fatigue impairs memory. Fatigue reduces attention. Fatigue impairs encoding. Fatigue impairs retrieval. Lack of sleep impairs memory consolidation. Lack of sleep impairs encoding. Lack of sleep impairs retrieval. Sleep is essential for memory. Sleep is essential for brain health. Protecting sleep protects memory. Memory is biological. Memory is physical. Memory involves neurons and synapses and chemicals and electrical signals. Memory is also psychological. Memory shapes our thoughts, our emotions, our sense of self. Memory connects us to our past. Memory allows us to navigate the present. Memory allows us to imagine the future. Memory is complex. Memory is dynamic. Memory is constantly changing. The brain is always working. The brain is always encoding. The brain is always storing. The brain is always retrieving. Most of this work happens outside of awareness. You are not aware of the neurons firing. You are not aware of the synapses strengthening. You are not aware of the consolidation happening during sleep. But all of these processes are happening. They are happening continuously. They are happening quietly. They are happening in the background. Memory is fragile. And memory is resilient. Memory can be disrupted by injury, by disease, by stress, by fatigue. But memory can also be strengthened through practice, through sleep, through a healthy lifestyle. Memory is shaped by experience. Everything you do, everything you see, everything you hear, everything you think can change your memory. Your memory is unique. No one else has the same memories as you. Your memories make you who you are. As we come to the end of this exploration, we return once more to this simple truth that memory is essential. Memory allows us to learn. Memory allows us to grow. Memory allows us to connect with others. Memory gives meaning to experience. Without memory, there is no continuity. Without memory, there is no story. Without memory, there is only the present moment, disconnected from past and future. Memory is happening now. As you process these words, your brain is encoding information. Neurons are firing. Synapses are changing. Some of this information will be consolidated. Some of this information will be forgotten. The information that remains will become part of your long-term memory. It will be stored in distributed networks across your cortex. It will be available for retrieval later. If the right cues are present, if the memory is strong enough, if your brain is rested and alert. The study of memory reveals the remarkable capacity of the human brain. The brain is not a static organ. The brain is constantly changing. The brain adapts to experience. The brain learns. The brain remembers. This capacity is the foundation of everything we do. This capacity is what makes us human. Memory is ancient. Memory evolved over millions of years. Memory is what allowed our ancestors to survive. Memory is what allows us to thrive today. In this moment, your brain is working. Neurons are communicating. Information is being processed. Some information is entering short-term memory. Some information is being manipulated in working memory. Some information is being transferred to long-term memory. Most of this activity is below the threshold of awareness. You do not feel the neurons firing. You do not sense the synapses strengthening. But the work is being done. The work continues. The work never stops. Sleep will come. When sleep comes, the brain will continue its work. The hippocampus will replay the day's experiences. Memories will be consolidated. Information will be transferred from temporary storage to more permanent storage. Synapses will be strengthened. Connections will be refined. The brain will prepare for the next day. Sleep is not rest for the brain. Sleep is active. Sleep is essential. Sleep is when memory is protected and preserved. When you wake, you will have access to your memories. You will know who you are. You will know where you are. You will remember the past. You will plan for the future. You will use working memory to think and reason and solve problems. You will use episodic memory to recall experiences. You will use semantic memory to understand the world. You will use procedural memory to perform skills automatically. All of these systems will work together. They will work seamlessly. They will work quietly. They will support everything you do. Memory is ordinary. Memory is extraordinary. Memory is happening all the time. Memory is so constant that we take it for granted. We do not think about memory until it fails. We do not appreciate memory until we lose it. But memory is always there. Memory is the foundation of consciousness. Memory is the foundation of identity. Memory is the foundation of life. The brain is a remarkable organ. The brain weighs about 3 pounds. The brain contains about 86 billion neurons. Each neuron connects to many other neurons. Each neuron can connect to thousands of others. Together, these connections form a very large network. The total number of synapses is very high. It reaches into the trillions. This network allows the brain to process information. This network allows the brain to store information. This network allows the brain to retrieve information. Memory depends on this network. Memory exists because of these connections. The network is active all the time. It works quietly. It works in the background. It works without effort. Memory is not perfect. Memory can change. Memory can sometimes fail. Memory can produce small errors. This is a natural part of how memory works. At the same time, memory is resilient. Memory can adapt. Memory can continue even when some details are lost. Even when a memory is hard to access. The information may still exist in the brain. The brain is flexible. The brain can adjust. The brain can continue to learn. The brain can continue to change across the lifespan. These changes happen slowly. These changes happen naturally. The brain manages these processes without conscious effort. The brain regulates its own activity. Neurons adjust their connections. Synapses strengthen or weaken over time. This allows information to be maintained. This allows information to be modified. The brain does not need to be directed. These processes occur automatically. They are guided by biology. They are guided by experience. They are guided by repetition. Memory continues to function during periods of rest. Neural activity does not stop. It becomes quieter. It becomes slower. Patterns of activity repeat. Connections are adjusted gradually. Networks stabilize over time. This ongoing activity supports memory. It supports learning. It supports adaptation. These processes are continuous. They do not end. They change form depending on the state of the brain. Neurons in the brain are arranged in layers. The outer layer of the brain is called the cortex. The cortex has 6 layers. Each layer contains different types of neurons. Each layer has different patterns of connections. Neurons in the upper layers often communicate with other areas of the cortex. Neurons in the middle layers often receive input from sensory systems. Neurons in the deeper layers often send signals to other parts of the brain. This layered structure allows information to move through the brain in organized pathways. It allows different kinds of processing to occur at the same time. This organization developed slowly over millions of years. The visual cortex is responsible for processing visual information. The visual cortex is located at the back of the brain. When light enters the eyes, it is converted into electrical signals. These signals travel along the optic nerve to the visual cortex. Within the visual cortex, different groups of neurons respond to different features of visual input. Some neurons respond to edges. Some respond to color. Some respond to movement. Some respond to complex shapes. These neurons work together to create visual perception. At the same time, they contribute to visual memory. The same neural activity that supports seeing also supports remembering what was seen. The auditory cortex processes sound. The auditory cortex is located on the sides of the brain. Sound waves enter the ear and cause vibrations. These vibrations are converted into electrical signals. The signals travel to the auditory cortex. In this area, different neurons respond to different sound frequencies. Some neurons respond to high tones. Some neurons respond to low tones. Some neurons respond to complex patterns, such as speech. When sounds are processed, memory traces are formed. These traces reflect the patterns of neural activity. When a sound is remembered later, similar patterns are activated again. The motor cortex controls voluntary movement. The motor cortex is located near the top of the brain. When a movement is planned, neurons in the motor cortex send signals through the spinal cord to the muscles. The muscles respond by contracting. Repeated movements lead to changes in the motor cortex. Connections between neurons become stronger. Movements become smoother. Movements become more consistent. Over time, movements require less conscious effort. This process supports procedural memory. This is how skills are learned. This is how skills are maintained. The somatosensory cortex processes touch and body sensations. It is located just behind the motor cortex. Different areas of the body are represented in different parts of this region. Areas with greater sensitivity have larger representations. When the body receives sensory input, neurons in the somatosensory cortex become active. This activity contributes to memory for touch, temperature, pressure, and pain. These sensory experiences can be remembered. They become part of the brain's stored information. Memory involves all of these sensory cortices working together. A complete memory of an experience includes sights, sounds, smells, tastes, and touch. It includes emotions. It includes thoughts. All of these different types of information are processed in different parts of the brain. The hippocampus binds them together. The hippocampus creates associations between the different sensory cortices. When you retrieve a memory, the hippocampus helps reactivate all of these different areas. The memory is reconstructed from distributed pieces. The memory feels unified, but it is actually composed of many separate components. The sense of smell is closely connected to memory. The olfactory bulb, which processes smell, has direct connections to the hippocampus and to the amygdala. This is unusual. Most sensory information passes through the thalamus before reaching the cortex. But smell bypasses the thalamus. This direct connection may explain why smells can trigger vivid memories. A particular scent can instantly bring back a memory from years ago. The memory may be accompanied by strong emotions. This phenomenon is sometimes called the Proustian memory effect, named after the writer Marcel Proust, who described how the smell of a Madeleine cake triggered childhood memories. Taste is also connected to memory, though less directly than smell. Taste and smell work together to create flavor. When you eat something, you are creating a memory that includes taste, smell, texture, and context. Food memories can be powerful. Food memories are often associated with specific people, specific places, specific times. Food memories can evoke comfort. Food memories can evoke nostalgia. The brain stores these complex, multi-sensory memories and retrieves them when similar cues are present. Emotional memories are particularly strong and long-lasting. The amygdala enhances memory consolidation for emotional events. When something emotionally significant happens, the amygdala activates. The amygdala releases stress hormones. These hormones enhance activity in the hippocampus. The hippocampus encodes the memory more strongly. This is an adaptive mechanism. Emotionally significant events are often important for survival. Remembering dangers is important. Remembering rewards is important. The brain prioritizes emotional memories automatically. But emotional memories are not always accurate. Strong emotion can enhance memory for the general event, but it can impair memory for details. This is because attention narrows during emotional arousal. You focus on the central, emotionally relevant information. You ignore peripheral details. Later, you may remember the emotional core of the event very clearly, but you may not remember the surrounding context accurately. This can lead to distortions. This can lead to false memories. Emotion enhances memory, but it does not guarantee accuracy. The passage of time affects all memories. Recent memories are usually more detailed than old memories. Recent memories include more sensory information, more contextual information, more specific details. As time passes, memories lose detail. Memories become more semantic and less episodic. You may remember that something happened, but you may not remember exactly when or where it happened. You may remember the gist of a conversation, but not the exact words. This is normal. This is how memory changes over time. The brain retains the essential meaning and lets go of unnecessary details. Some memories remain vivid for a lifetime. These are often memories of highly significant events. People often remember exactly where they were and what they were doing when they heard about major historical events. These are called flashbulb memories. Flashbulb memories feel very vivid and very accurate. But research has shown that flashbulb memories are not always accurate. They are subject to the same distortions as other memories. They feel special because they are emotional and because they are rehearsed. When a significant event occurs, people talk about it, they think about it, they rehearse the memory. This rehearsal strengthens the memory, but it can also introduce errors. Rehearsal is any process that involves thinking about or using a memory. Rehearsal can be intentional or unintentional. Intentional rehearsal occurs when you deliberately try to remember something. You repeat information to yourself. You practice retrieving information. You study. Unintentional rehearsal occurs when a memory comes to mind spontaneously. You think about a past event. You daydream. You reminisce. Both types of rehearsal strengthen memory. Both types of rehearsal can also change memory. Each time you retrieve a memory, you reconstruct it. Each reconstruction can introduce small changes. The act of remembering changes the memory. This is because retrieval makes the memory temporarily unstable. After retrieval, the memory must be reconsolidated. During reconsolidation, new information can be incorporated into the memory. This is how memories are updated. This is how memories adapt to new information. But this also means memories can be distorted. If you retrieve a memory in a different context, the context can become part of the memory. If you retrieve a memory while experiencing a strong emotion, the emotion can become associated with the memory. Memory is dynamic. Memory is not fixed. The hippocampus gradually becomes less important as memories age. This process is called systems consolidation. Systems consolidation can take months or years. During systems consolidation, memories are transferred from the hippocampus to the cortex. The connections between cortical regions strengthen. The memory becomes less dependent on the hippocampus. Eventually, the memory can be retrieved without hippocampal involvement. This is why people with hippocampal damage often have intact memories from long ago, but cannot form new memories. The old memories have been consolidated in the cortex. The new memories cannot be formed because the hippocampus is damaged. Different memories consolidate at different rates. Simple factual memories may consolidate quickly. Complex episodic memories may take longer. Emotional memories may consolidate more quickly than neutral memories. The rate of consolidation depends on many factors. The importance of the information matters. The amount of rehearsal matters. The presence of emotion matters. Sleep matters. All of these factors influence how quickly and how strongly memories are consolidated. The brain is always balancing stability and plasticity. Stability means that memories are preserved over time. Plasticity means that memories can be updated and changed. Too much stability would mean the brain cannot learn new things. Too much plasticity would mean memories are constantly being overwritten. The brain needs both. The brain needs to preserve important information. The brain needs to adapt to new information. This balance is maintained through complex biological processes. This balance is maintained through the interaction of many brain systems. Memory is related to attention. You cannot remember what you did not pay attention to. Attention determines what information enters the memory system. When you pay attention, neurons that process that information become more active. The activity is stronger. The signals are clearer. Encoding is more effective. When you are distracted, attention is divided. The signals are weaker. Encoding is less effective. Later, retrieval is more difficult or impossible. This is why multitasking impairs memory. When you try to do several things at once, attention is divided. None of the tasks receives full attention. Memory for all of the tasks suffers. Attention is limited. The brain cannot process everything in the environment. The brain must select what to process. Selection is based on many factors. Relevance is important. Novel information captures attention. Emotional information captures attention. Expectations influence attention. If you are looking for something specific, you are more likely to notice it. If you are not expecting something, you may not notice it at all. This is called inattentional blindness. Information that is not attended to is not encoded. Information that is not encoded cannot be remembered. Working memory and attention are closely related. Working memory allows you to hold information in mind while you use it. Attention determines what information enters working memory. Attention also protects working memory from distraction. When you are focused, irrelevant information is filtered out. Working memory can maintain the relevant information. When you are distracted, irrelevant information intrudes. Working memory becomes overloaded. Performance suffers. This is why a quiet environment is better for studying or working than a noisy environment. Quiet reduces distraction. Less distraction means better attention. Better attention means better encoding. Better encoding means better memory. The prefrontal cortex plays a major role in controlling attention. The prefrontal cortex sends signals to sensory cortices. These signals enhance the processing of relevant information. These signals suppress the processing of irrelevant information. This is called top-down attention. Top-down attention is voluntary. You decide what to pay attention to. The prefrontal cortex implements that decision. Bottom-up attention is different. Bottom-up attention is automatic. Salient stimuli, like loud noises or bright lights, automatically capture attention. Bottom-up attention does not require effort. Bottom-up attention can override top-down attention. This is why it is hard to ignore a sudden loud noise, even if you are trying to focus on something else. The ability to control attention varies across individuals. Some people can maintain focus for long periods. Some people are easily distracted. These differences are partly due to differences in the prefrontal cortex. They are also influenced by stress, by fatigue, by motivation. When you are stressed, the prefrontal cortex is less effective. Attention control suffers. When you are tired, maintaining attention requires more effort. When you are motivated, it is easier to sustain attention. Motivation enhances activity in the prefrontal cortex. Motivation makes it easier to ignore distractions. Motivation also affects memory. Information that is personally relevant or interesting is remembered better than information that is not. This is because motivation enhances attention. Motivation also enhances encoding. When you are motivated to learn something, you engage more deeply with the material. You think about it more. You make connections to existing knowledge. Deep processing leads to stronger memories. Shallow processing leads to weaker memories. The level of processing during encoding determines how well the information will be remembered later. The levels of processing framework was proposed by researchers Craik and Lockhart. They suggested that memory depends on how deeply information is processed during encoding. Shallow processing focuses on surface features, like the appearance of words. Deep processing focuses on meaning. Deep processing creates more connections. More connections mean more retrieval pathways. More retrieval pathways mean the memory is easier to access later. This is why understanding information is more effective than simply memorizing it. Understanding requires deep processing. Memorization can be done with shallow processing. Deep processing creates stronger, more durable memories. Elaboration is a technique that enhances deep processing. Elaboration means adding meaning to information. Elaboration means connecting new information to existing knowledge. When you elaborate, you create a richer memory trace. You create more associations. More associations mean more retrieval cues. If one cue fails, another may succeed. Elaboration takes effort. Elaboration requires thought. But elaboration is one of the most effective ways to improve memory. Students who elaborate while studying remember more than students who simply read or repeat information. Organization is another technique that enhances memory. Organization means structuring information in a meaningful way. Organization means grouping related items together. Organization means creating categories or hierarchies. When information is organized, it is easier to encode. It is easier to store. It is easier to retrieve. The brain naturally looks for patterns. The brain naturally organizes information. Providing an external organization makes the brain's job easier. This is why outlines, charts, and diagrams are helpful learning tools. They provide organization. They make relationships explicit. They support memory. Now, your mind is calm. Your memories are safe. Your thoughts can drift like clouds, slowly, gently, quietly. All that you learned today, all that you experienced, is being stored, protected, ready to serve you tomorrow. There is nothing else you need to do. Nothing to plan. Nothing to remember. Everything is taken care of. Sleep is here. Sleep is natural. Sleep is gentle. Sleep will carry you through the night. Your memory, your mind, your body all rest now, peacefully, safely, completely. Good night, beautiful soul. Sleep and dream, and let your mind continue its work, quietly, softly, all through the night.